Hey guys, this is Mike Keenan here. Today I want to go over the Address Resolution Protocol, otherwise known as ARP, and I want to describe what it is, what it does, and why it does it. There's a lot of information out there on the internet, but most of it falls short in accurately describing the full functionality of ARP. They say that it resolves an IP address to a MAC address, and it has been my experience that the majority of the information out there, that's where it ends. So in this tutorial, what I'm going to do is explain how a workstation uses the address resolution protocol to talk to hosts on its own network, as you see here in the blue subnet, and also how the address resolution protocol is used to facilitate IPv4 communication to web servers or other hosts in other subnets. So we have over here in the blue, we have the 10.1.1.0/24 network. And over here in the green, we have the 10.2.2.0/24 network. And let's get into it. So in our first example, the workstation is going to be talking directly to the web server, and the web server is in its own subnet. And just a quick review, I'm going to go over the different layers of the TCP/IP model. And at the top you have your application layer. Just below it you have your transport layer. Just below it you have the network layer, otherwise known as the internet layer. Down below it at layer 2 you have the data link layer. And at the very bottom you have the physical layer. So up here at the application layer, that's your data. Down here at the transport layer you have your segments. Down here at the network layer, we change the color, you have the packet. Down here at the data link layer, you have a frame. And down here at the physical layer, you have your electrical impulses that go over the wire, your bits, your ones and your zeros. And each one of these is what is known as a protocol data unit, otherwise known as a PDU. And just so you're aware, ARP exists here at layer 3. It is a layer 3 protocol, but what it does is it works at the network layer and also at the data link layer to translate that IP address to a MAC address. So technically it's at the network layer, but it's used at the network and the data link layer. So let's see how this works. So the workstation here, he knows that he exists in the 10.1.1.0 network because he's 10.1.1.15. So he's smart enough to know that this web server down here, which is in 10.1.1.25, is in his same network. So in other words, any host between 10.1.1.1 all the way through 10.1.1.254 are valid hosts within that subnet range. So because these two IP addresses are in that subnet range, the workstation will communicate directly to the web server at layer 2. That also makes it a lot faster than if it would have to go over into a different network. The packet would have to be processed by a router and then make it to the web server and then come back. But we'll explain that here in a little bit. Just know for now that there needs to be a layer 2 adjacency between the workstation here and the web server down here, and that they're going to communicate to each other directly at layer 2. So let's see that in action. I'm going to put a capture on this wire here. I'm also going to put a capture on this wire over here at the router. Alright, so we're going to filter on ARP. And we're going to log into our workstation, which we already are over here. So this terminal is this workstation here. And I'm going to ping from the workstation down to the web server. But something's going to happen first. First, he's going to have to send out what's known as an ARP broadcast. And let's see what that looks like. There it goes. Let's look at our captures. So there it is. You see it here. We have the ARP broadcast request being sent out. If we were to look at it down here, you'll see that the target MAC address is 000000000000, and that is the broadcast address for ARP. That's what it's going to send it out to, and it's going to send it to the switch. And once it gets received at the switch, what's going to happen there is the switch will get the information. He'll get the packet. It'll come in here on this interface. The switch will then broadcast it out this interface, and he'll broadcast it out this interface, and he'll wait to get a return, an ARP unicast reply. And once he gets that, he'll populate what it's known as his MAC address table with the MAC address of the devices that are on those different interfaces. So in this case, we have the switch has 3 different interfaces that are connected right now. Gig 0/0, he has gig 00, and he also has gig 01. So now he'll populate his MAC address table with, and what I'm going to do throughout this tutorial is I'm always just going to use the last 4 digits in the MAC address, so he knows how to get to 0C93EE2A 2500. He knows how to get there because he exists out of his gig 0/1 interface. And what you'll also notice is he sent out the ARP broadcast out of this interface as well to the router. And if there's another device plugged in, say there's another device plugged in at the top here, say there was a hub there, and he had an interface here, and he had an interface there, and there was a computer over here connected to the hub, and another computer over here connected to the hub. What would happen is, because the hub is a layer 1 device, it doesn't have a processing unit, it doesn't have memory, it has a bus in it, and then what it does is it just broadcasts all the time the broadcast ARPs out of all of its interfaces. Now the difference between that and a switch is the switch is a smart device, and the switch has a processor, it has RAM, and it's running an operating system. And what it does is it's able to keep that MAC address table up to date, and it makes it super efficient. It makes it much more efficient than a hub. Because hubs, what they do is they just transmit whatever comes in, they transmit it out all of the interfaces, and that's when you have protocols like CSMA, CD, and these legacy protocols that were designed to prevent collisions on the network. Well, with the switch, you have a very low probability of getting collisions. In fact, they call each one of these, like this here would be called a collision domain. This one here would be called a collision domain, because once he learns the MAC address for an individual host, he ceases to send out, he ceases to transmit any other information out of that interface. The only information he's going to transmit is the interface destined to whatever MAC addresses exist out of that interface, because he's able to remember that information. So when he broadcasted that ARP request out of this interface and it got here at the router, as you see up here, that's this guy here, the router got it, and the router saw that the destination that he was looking for was 10.1.1.25. Well, the router's 10.1.1.1, so when he received that ARP request, he dropped it and allowed the web server down here who's at 10.1.1.25 to respond, which indeed the web server did respond here. So the web server directly responded to the host, to the workstation at target IP address 10.1.1.15. So that's how ARP works in the same layer 2 segment, or the same subnet. But now I want to explain how it works when a workstation has to communicate to a host outside of his subnet. So let's just say that the workstation has to communicate with web server number 2. So he's got to go from here all the way to here. Now how is that going to look exactly? Well, is he going to be able to communicate directly at layer 2 to the web server? No, he's not. And the reason for that is because he's unable to form a layer 2 adjacency with the web server, because the web server exists in, or web server 2 I should say, exists in 10.2.2.0/24. So he's in a different subnet than he is, and now the workstation is also smart enough to know that, hey, that guy is not in my subnet, so how do I communicate with him? Well, he should have been already set up with what's called a default, or his default gateway, the way that he's able to communicate anywhere outside of his own subnet. This blue subnet here, he has to communicate with his default gateway, and his default gateway has to get him off of his network. That's the default gateway's job. So what he's going to do is he's going to send an ARP request, not to the web server, because he can't do that. He can't send an ARP request to the web server. So he's going to directly communicate with his default gateway at layer 2. But the rules still apply. So what he's going to have to do is send an ARP broadcast. Let me use green now. He's going to have to send an ARP broadcast out of all the interfaces. The switch is going to send it anyways to the router. So he sends the broadcast out, the switch receives it, the switch sends it to the router gets it, and then the router's going to do a route lookup, and he'll see that he has an interface in that same subnet. So what he'll do is he will rebroadcast the ARP request, because he has to also do a resolution as well. He's going to resolve the web server's IP address and do the same exact thing that the workstation had to do over here. So again, let's see that in action. So what we're going to do is ping from the workstation. Right now I'm connected to the workstation, and I'm going to ping web server 2. So ping 10.2.2.25. Let's see what happens on this capture. So right now this capture is between switch 2 and web server 2. So let's look and see. There it is. So you see the router, so his MAC address ends in 2201. See it there? And the web server is at 8D00. So again, you'll see all zeros. He's broadcasting it out. This is from the router to all hosts that are in the subnet. And the web server receives it, and you can see because this is his MAC address. This is the source MAC address, and he's sending it directly back to the router. So let's look at what that looks like on the router. So let's do a show IP ARP. And there it is. This is his ARP cache, his ARP table. So he has an ARP entry for the web server at that MAC address, and he also knows that it exists out of his gigabit Ethernet 0/1 interface. And let's also look at what it looks like on the switch. So there it is. You'll see his gigabit 0/0 interface has associated with it the MAC address of the web server 2. There it is. Now, because this is a layer 2 switch, you won't have an ARP cache. It's only until you turn it into a layer 3 switch that you'll have an ARP cache. So for this tutorial, we're not going to get into that. We're just going to keep it simple and show the basics of how ARP works. And if we wanted to, we can also log into the workstation as well. And we can do ARP-N on this Linux box. And you can see he also, in his ARP cache at the workstation, has an entry for web server 1 here, 2500 at 10.11.25. So that's how ARP works. I hope you enjoyed this video. I hope you learned something, and we'll see you in the next one. Thanks.